rate constant will never be negative. Okay, so if you figured out the value of the rate constant, find...
Which is K.
The slope is A.
So you're trying to find the slope, which
on
is
your
A.
linear, yes. Your slope is A.
And he's just doing, like, this is our sheet. We're just doing the back of it. So it's first order?
The zero and first order slope is negative K. It's negative slope. The second order, because
Oh,
that...
and I have this little note
Does
card
this Jimmy Jobber?
for most of the stuff we need.
Positive K.
Like on Promise 31, we need a number one.
Find your rate constant by plugging
I'm sorry?
your values into the
I haven't. I put my calculator because I didn't know we were still doing it. So,
because it asks in part, do you determine the value of the rate constant? So what I did is I used the second order equation and then solved for K. Isn't K the rate constant?
This is what's going on.
But this is in minutes, and I didn't know if you wanted rate constant in seconds. Oh, well, I put it in seconds.
Did I do? What did I do?
There you go.
Oh, I put it in seconds.
Yellow. Blue.
You can leave it in minutes, it's fine. Unless it specifically asks
I
for
don't know what I'm doing. I think it's first order.
the rate constant in specific, whatever time it is, fine. What do you mean you think it's first order?
I don't.
There's no way it's first order. Second order.
Second order.
Right, you gotta get your lists right.
I didn't put my list.
So what did you
So
do?
not in it.
This is your X. So when you do your linreg,
Put that first.
yeah, this put X as L2. And then if you're looking at the first one, Y would be L1. On the next one, Y would be L3. And the last one, Y would be
So we're supposed to put it
L4.
in how it is up there, not switch it up. Or does it really matter if we still put in?
Time has to be on the X,
Yes.
which is by default your first listed on your linreg.
So what did you get for the rate constant in seconds?
That one I got. For second order?
1850.
Oh boy. So it's just the slope? Because I thought last time we had to like put it into an equation and solve.
Okay, so two different scenarios right there. If you have concentration and time data, we know that we need this approach. Like we've got to start plugging it in our lists and that figure out the order and then we can figure out the slope. If you have a specific piece of information, like let's say you have the initial
I
concentration
hate it when my diagnostic isn't
and
on.
the time. Then we know we're gonna go to those equations, those integrated equations to solve.
Oh, okay.
Now what you did is still valid, but the problem is that K over time averages itself out.
Okay.
So yours would have been a little bit different?
I mean, like, is it?
Because I used the first
Are they the same?
like concentration,
Okay, what'd you get for K?
0.5.
Okay.
Which is,
I thought they
yeah,
were.
that's why I was like, it's not right because.
Oh,
It's all goofy.
no, you're right, I went the wrong way.
Okay.
I multiplied instead of divided, yeah. Yeah, you're good.
Yeah, you're really close.
Yes.
So it's just 32 is the K? That's it?
Did you get this?
Yes.
She's no. You have to be cool. Like, you gotta make it.
You tell it to run a linear regression.
Which the base help.
So K is probably.
What? K is the A.
Oh, K is the
Okay, so I think,
Do we need our diagnostic? The R?
I guess not. I kind of freaked out about it, but for no reason. So I've got it right here. Apparently L4 was the best one. So I, plug that in, calculate.
Internet went out that afternoon.
That's the line. NA,
Everyone
that's
was
your
very
rate
excited.
constant. So your rate constant, which is K, is 32.
Oh, she graded
Probably.
her test, you guys.
Oh, brother.
I'll put you back.
I got a 78.
Calculus test?
Man, I literally had my hand on my head the whole test.
Oh my gosh, I did better than I thought I would.
And right after she's like, was it as bad as you thought? And I was like, yes. It was
Here, I'm
actually
gonna
probably
text the
worse
group
than I
chat.
thought.
Please hold on.
Mr. Rowboat. Mr. Roland, Mr. Roll C,
Roland, we'll see Roland.
Roll Fire, Roll Wind, Roll
I feel okay now.
The Four Nations live together.
Would you like the last ones?
I know first order is one.
Take.
Get it. Copy one.
She must have given us a curve.
Oh yeah, she definitely gave us a curve. And I was like, what? I was like, I did not think I did that good.
She curve our test.
She usually does like a square root curve.
I don't know if she could curve though, if like Psalm got a 96.
I did just curve. I did a lot.
Not much curve in there.
No, I thought, I was like, I made a, let's see, I guess. I was like, no, I was like 60 to 70 was what I thought I was gonna make, somewhere in there.
I probably, first off, we probably got a curve, and I probably got a lot of partial credit, because on the no calculator, I didn't solve everything out all the way, because I didn't know how to.
Well, and she told us, because, for the calculus exam, they tell you that you don't have to simplify. So for the ones that we didn't have a calculator, I didn't simplify anything,
Either did I.
because it was 1/3 pi.
The first time in almost a year.
How do you simplify that?
I know, I have an A right
So
now.
I left it, I left it. 3 pi to the negative 1.
Is that like you can't have a radical in the denominator, so you can't have pi in the denominator?
Well, for the AP exam, like, she's having y'all rationalize, because for calculus, the criteria requires that you do so. And it's probably because they want to make sure that you have that foundation. But once you get to calculus and you practice that foundation, it's not as necessary. You know what you're doing. But even so, for like the first semester, she still had us rationalizing radicals. And she kept going back on her about it. But it's to the point now where she's like, don't rationalize anything.
Girly.
So she's hit or miss. That's what I'm saying. She's at a script, but anyway.
Oh, okay.
Alex did a bawling emoji. He said, yep, bawling. I'm like, I doubt he did that.
He's such a baller.
I'll tell them what I got, maybe they'll give her.
What did you make? Exclamation point.
Alright, so if
I'm
you
just gonna
missed
go like an 82.
yesterday,
Wait, did you say 85, Lexi?
alright, so here's the correct
What? Did you
equation
say you made an
for 4, 5, and 6.
You. We're gonna have it later.
Mm-hmm. Yes.
You don't need this equation because none of
Oh,
those.
are you helping?
Am I gonna need a future comment?
Yeah, this is
You
this
want
is
me
for
to
the problem
take
set,
that
Kendall.
problem? Absolutely, yes. Absolutely.
Okay, that's what I was asking. You're just helping the juniors. Okay.
So Coach Fryer, you
Okay.
should fill that application.
That's the equation.
Absolutely.
We already did that on number 4. We already have it, but
Today,
So, the last time they hosted the state softball
send our
tournament here,
SAR
one of the schools had
dang, y'all
the
did
ability
better.
to broadcast the game, but nobody
I can
to
show you
actually
how to do it,
announce
so
it.
that might be what that is.
So Coach Fryer,
And it might also be
Announced
about
it.
the summer program.
and then Coach Wright was down the play-by-play.
We're done with
and
that.
he kinda threw
Well,
it
I'm
over
proud
to
of them though, because
Coach
they weren't
Fryer,
here for like
and
weeks on
most of her responses were absolutely.
Kendall, say
Yes.
hi to the camera.
Hi. Was that
Yeah,
good enough?
Absolutely.
Okay.
You were
Are you just
Alright, so
filming
in
this
this-
rolling?
Mhm.
So here are your Ks.
Okay.
Yes.
Okay.
Here are your Ks. Okay, this has to be in joules. Right, so the activation energy in 4 is 102 kilojoules.
Mm.
Right, so we gotta make this 102,000.
Mhm.
R is your energy, R, so 8.314. Temperatures have to be Kelvin,
Kelvin.
314. Plus 276. So at 4, you're trying to solve for one of the K's, and 4 and 6 both. And then 5, you're solving for one of the temperatures. I think we looked it up yesterday, right?
What?
4, 34.
So did you understand?
Yeah, because we worked it out like 2 different ways.
Wait, is it? Wait. What K is on top? Is it K2 or K1? Which one? K2 is on top. That's just the equation. That's what I was wondering.
Except for that one. I'm just kidding. Okay. I'm so mean, I'm sorry.
Oh no.
Okay, that's because that's including. I thought you were still allowed. Okay. I just turned it in, but I think I have membership, so I can just.
Wait, what? But you're trying to calculate a temperature.
Oh wait. I'm doing it wrong.
Oh, he's still doing number 4. Okay, never mind. I'm sorry.
I was using L1.
I think the reason yours is bigger is because your slope was bigger than mine. Because my R squared wasn't as accurate.
Hmm.
But if you want me to check it, assuming that this is your slope, I would.
Okay, so you have the starting.
So when you
I would get the same.
do all of that,
Well, yours actually changed a little bit when I typed it in. So if you do 8 and then 4, and then it's negative 2 6's.
Okay.
That's what you have on there.
Okay.
With this.
so from here,
And I typed in
I have to get rid of this natural log, so I'm gonna take E to both sides.
Mhm.
And then we got
Oh, we already did number 4.
So yours shouldn't be wrong.
this side.
Should I say that? Do I?
Because
Oh,
whenever
I
I
already said.
typed it in, my R squared was like
It's just funny how
0.97. So it could have
I'm
been
just
a little bit, but it's all relative. As long Oh, sorry, am I in the way? Sorry.
No, I was zooming in on you. I think, Mr. Rowland, I think we can probably live with 4 through 6, but I don't know if we know how to do 7 and 8.
7 we don't have to do. Overkill.
Okay, and then H? Oh, determining the activation energy. Oh,
Alright,
but you only have
so
one
in
temperature.
8. So you need to create 2 new columns. 1 over temperature in Kelvin, and then natural log of K. So I kind of show you why. So this is your Y, the natural log of K, and then this would actually be your slope, and then the temperature would be your X. So you're gonna go back into your lists. And we're gonna put this in for L1, this in for L2. Run a minreg. So this one's a little bit different from that problem we were looking at on pre-lab. If you run your linear regression right here, the slope is actually going to equal the negative activation energy divided by R. Okay, so to find that activation energy, you're going to take your slope and then multiply by R, and then we're going to switch the signs.
So that's where you said
No, you just need slope. And R is still 8.314? Okay.
It's very similar to what we were working on the pre-lab, just with, we have to switch our units a little bit.
Okay.
And then our slope.
That's pretty easy.
Equal our activation energy, we have to multiply by R.
Okay, yeah, no problem. Okay. So, come on. You can do it. You can do it. That's good enough. You're going to do these two tables? X, Y, plug them in, get your equation. You have your slope. You're trying to find activation energy. So then R times your slope. There's your R. You need the slope, which you get from this equation. And that's it.